Hello GATE aspirants, welcome to part 6 of GATE Thermal and Statistical Physics series. Question number 20. In Bose-Einstein condensers, the particles, option A, have strong interparticle attraction. Now Bose-Einstein condensers do not necessarily have strong interparticle attraction. It can be weak or even repulsive. So option A is wrong. Option B, condense in real space. Bose-Einstein condensates are characterized by particles occupying the same quantum state, which is leading to macroscopic occupation of the ground state in momentum space. So rather than condensing in real space like droplets of liquid. So option B is also wrong. Option C, wave functions, they have overlapping wave functions. So wave functions of the particles, they overlap significantly, which leads to coherent microscopic quantum state. So option C is correct. Option D, have large and positive chemical potential. Now chemical potential is typically 0 or very close to 0 at absolute 0 temperature. As the particles, they will try to occupy the lowest energy state. So this is also wrong. Next question. Consider a system of n non-interacting spin-half particles, each having a magnetic moment mu, is in a magnetic field B bar is equal to Bz cap. If E is the total energy of the system, the number of accessible microstates, omega, is given by. Now each particle, it is a spin-half particle, so each particle can have one of the two energies. If it is spin up, then it will be minus of mu b when it is spin up, and it will be plus of mu b when it is spin down. So these energies are possible. Now total energy will be equal to this energy n up. So these are the number of particles having spin up into their energy minus of mu b, plus we have spin down particles into their energy, that is mu b. Also total number n up and n down, that will be equal to capital N. So here in this equation we can write n is equal to this minus sign n up mu b plus n down is equal to n minus n up into mu b. So we can take mu b common. So E is equal to n minus 2n up into we have mu b. So E by mu b is equal to n minus 2n up. So from here n up is equal to, this will be minus of this upon n. So this will be n by 2 minus of half into E upon mu b. And similarly n down will be n by 2 plus half of E upon mu b. Now the total number of microstates is, we have to choose the number of particles which are having spin up. So this is nc n up. So that is n factorial upon n up factorial into this is n minus n up factorial, which is n down factorial. So this will be equal to, we have n factorial, and in the denominator n up is this, we can take half common. This will be half minus E upon mu b factorial, and here also half n minus, it will be n plus E upon mu b factorial. So here option A is correct. Next question. For a black body radiation in a cavity, photons are created and annihilated freely as a result of emission and absorption by the walls of cavity. This is because option A, chemical potential of the photons is 0. This statement is true, and photons, they do not conserve particle number. Here chemical potential is 0, that means it allows for the number of photons to adjust freely in response to changes in temperature and energy. So that facilitates their creation and annihilation. So option A is correct. Now for option B, photons obey Pauli's exclusion. Photons are bosons and they do not follow Pauli's exclusion principle. Option C is photons are spin 1 particles. The entropy of the photons is large. Now these two statements are true, but that does not explain the ability of photons to be created or annihilated freely. So here option A is correct. Next question 60. The entropy of a gas containing n particles enclosed in a volume V is given by this expression, where E is the total energy, A is a constant, Kb is Boltzmann constant. The chemical potential mu of the system at temperature T is. This is given, S is given, and chemical potential mu is equal to minus T dou S by dou N at constant V and E. So we have to take derivative with respect to n, and this is the expression we have. So here we have two n terms, here and here. So this can be written as minus T in bracket. First we'll take n derivative of u. So that will be Kb ln of Av e raised to 3 by 2 n raised to 5 by 2 plus we have first term as it is, that is n Kb. Then we have ln of this. So we have dou by dou n of this ln of, and this can be separated. We can write it like this: Av e raised to 3 by 2 minus of ln of n raised to 5 by 2. So this is the whole thing. Now the first term, this remains as it is, and in the second term, in this first term there is no n, so this will be 0, and just derivative of this we have to consider. So mu is equal to minus of T, we can take Kb outside, so this will be ln of this Av e raised to 3 by 2 n raised to 5 by 2 into we have plus n Kb. Now dou by dou n of this, so this is with minus sign, so here we will have minus sign. Then derivative of this is ln of n raised to 5 by 2, so that is n raised to 5 by 2 in the denominator, and derivative of this, so this will be 5 by 2 into n raised to 5 by 2 minus 1, so that is 3 by 2. So n into n 3 by 2 upon 5 by 2, so this will cancel out. So finally we will get, and here I am taking Kb common, so this is also I am taking outside. So mu is equal to, we have minus T by Kb into this ln term minus this n raised to 3 by 2 upon n raised to 5 by 2 will cancel out, minus 5 by 2. So this is the case. So here option A is correct. Next question. The average energy U of one-dimensional quantum harmonic oscillator of frequency omega and in contact with heat bath at temperature T is given by. Now average energy is equal to half of h cross omega plus h cross omega e raised to h cut omega, and into we have beta minus 1, because 1 by kt is beta. So here we can take 1 by 2 h cut omega common, so this will be 1 plus 2 e raised to h cut omega beta minus 1. Half into h cut omega, this will be e raised to h cut omega beta minus 1 plus 2 upon e raised to h cut omega beta minus 1. So u is equal to half h cut omega, in bracket we have e raised to h cut omega beta plus 1 upon h cut omega beta minus 1. So here we have to write in terms of cot h, tan h, sin h, cos h, like that. So we know cot h hyperbolic. So cot hyperbolic of x is equal to cos hx upon sin hx, which is equal to e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Now we can throughout divide by e raised to minus x, so this will be e raised to 2x plus 1 upon e raised to 2x minus 1. So this is similar now. So x is equal to 2x is equal to this thing. So here we can write u is equal to half into h cut omega. Then here we can put cot h, and here x is equal to h cut omega beta by 2. So here option A is correct. So these were all the questions from GATE 2015 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.